Okay, so today we're going to review long division and synthetic. You have a little quiz on that today, a homework quiz. It's only in the 85 or in the 15% category. It's no big deal, but it'll give us both a good idea of if you get it or not. We're going to make sure you know how to interpret results of the synthetic. That's really important, especially for today's homework. As in, you got all these numbers, then they just kind of look like a big grid of numbers when you're done with synthetic. Do you know what they mean? And then placeholders. It's good to practice that too. And the new stuff for today is called the rational root theorem, and you'll learn why we need that in just a minute. So to start with on your scratch paper, would you please take this one right here and make it into, or use long division to see if that's a root, and then you do synthetic on it just to double check yourself. Okay? I'll pause while you do that. Okay, you put x squared on the top first. You're starting off well. Keep it going. Okay, changing signs around, agreed. They all cancel. Why do I drop down 2? I thought I just dropped down 1. Because why? Well, so you just always bring down everything that's up there? Well, then why? Ah, so I want to have 2 because there's 2 here. It needs to match the 2 here. Okay, good point. All right, move on. Now what? Okay, you put a 2. Positive or negative? Okay. And then you got 2x, and then you got minus 2, and then you change the signs, and then what happens? And therefore, it works. And therefore what? Therefore, you get the problem right, and therefore what?
We know that goes into that.
Okay, that goes into that, and therefore?
That is the root that deals with that.
Oh, then therefore this is a factor that goes into this, and therefore what's the root? This isn't the root. That's, no. What?
No, negative 2. Wait,
You're so close. Therefore, what is a root? See, you're thinking this is a root. That's not a root. There you go. Therefore, 1 is a root. And therefore, if I graph this thing, 1 would be an x-intercept of it. All right, good. So now, I'm always trying to get you to understand what it really means, other than just, oh, it worked. Okay, so the synthetic of this would have been to try 1 like this. And 1, and -1, and 2, and -2. And you should always check to see if you needed placeholders. Did I need placeholders on this one? No. So I dropped the 1 down, and I got 1. 1 times 1 is 1. Add them, 0. Multiply them, 0. Add them, 2. Multiply them, 2. Add them, and I got 0. And it works. And I could have interpreted this one and said, oh, this 1 means x minus 1. And this down here means 2 and 0 x's. I don't even have to write that. And 1 x squared. So it's x squared plus 2 and x minus 1, just like here. Okay? That's what you have to do on the quiz today. How many of you feel comfortable that you're going to do well on that? Good. Then let's move on and try the kind with placeholders. This one, if you try it without placeholders, I know some of you struggled with this last night. If you try it without placeholders, you're going at your own risk. It's like going out onto the beach in Los Angeles when they say there's sharks in the water. You could probably do it. You'll probably survive, but you're taking a big risk. Instead, just use placeholders. And does the other side need any placeholders? Yes, it does. So even though this part right here will cancel, and you could say there's 0x to the fourths left, I don't need a placeholder there. You kind of want that first term to cancel. So then the next one is 2x to the third, and then the 0 and the 0, and again it makes 0, but we want a placeholder. That's the point. Keep the 0x in there. And then this one cancels, and again, I could just say it's nothing there, but it's smarter to hold the place with plus 0x to the firsts. And then I can drop my 2 down. Now notice I have a 1, 2, 3, 4 part in the front and a 4 part here. If you would have let these be like gone, then it would be a 4 part going into a 2 part, which would be more confusing. So, all right, keep going. I'm going to say, how do I match this first term with that? I need a 2. So 2, and then I have 2x to the third. 2 times the 0 makes a 0. 2 times the 0 makes a 0. And I'm being more sloppy here because I know, look at that, it's all matching up perfectly. So when I change the signs, it all drops out, and then I'm done. And there it is. Raise your hand if you had x plus 2. Good. Do you think that would have been faster with synthetic? Exactly. Can't do it with synthetic. Because why? Because we can only test things with synthetic like test 1 or test 2. You can't test something that's a binomial like this, x to the third plus 1 with synthetic. Yes? You may, if you choose to not use placeholders on the quiz, and even if you could have used them, you don't have to. Okay, bottom line answer, the question was, do you have to use placeholders? The answer is no. It's up to you. But I will just warn you that when, especially you have placeholders on the left side, they're really hard to do without those placeholders. And if there's only one missing placeholder, you can usually get away with it. It's when there's like 3 like this, like 2 here and 1 here, that it can be really tricky if you don't use placeholders. So don't have to. My rule in general is as long as you show me your work, you can do it any way you want to. But you have to show me your work. If you can seriously guess and check your way to doing the problems on the test, that's fine. You just had to show me your work. Okay? I don't want to be that teacher who says, you have to do it my way or it's wrong. As long as you show me what you did, that's the main key. All right. This is why we need the new thing called rational root theorem. Now, I want to start giving you notes for this semester. And this is the first thing that I think we should put in the notes for this semester. So would you please take out something you can keep. This is not scratch paper you will throw away. This is notes you will keep that you can use then to study for the final with. Because before you know it, we're going to turn around and it'll be past spring break already. And it'll be like only another month, and then all of a sudden, poof, finals are here. And my results on the last final were awesome. I'd love to see you guys average an A- again. That was unbelievable. But to be able to study the second final is a lot tougher than the first final. Second semester final is harder. So this will be a great resource for you to use to study. So on your notes, I'd like you to title it Rational Root Theorem. And this is why we need the rational root theorem. Because sometimes you don't know what to test. Like if you tell me to test like x plus 1 here, then I know how to do it. But what if I don't tell you what to even try? Well, there is a theorem that tells us what are the only things that are possible. Like if I could look at this equation here and say, oh, I can look at this and I could tell you right now that 1 and 2 are the only things that are even possibly going to be roots. Well, then I can try both of them. I can try, testing 1 and testing 2. And you guys really don't like long as much as you like synthetic, right? You like synthetic better? And that's what you can use today. You can use long if you want to, but it's a lot longer. So we're going to use synthetic to tell whether or not the roots we find are actually roots. But we know the only things, from looking at this one, I can tell you the only possible roots of that are 2 or 1 or -2 or -1. It's always could be positive or negative, but all right. And I'm going to give you it's not always as simple as 2 and 1, of course. Here's the definition of rational root. I would not write all of this down in my notes. What I would write under rational root is that you can use it to get a possible list of factors to start the problem. And then I would definitely write this F-con over F-co. That stands for factors of the constant over factors of the coefficient.